This video is going to cover a review of Chapter 2, Section 6, which was combining and composite functions. Remember that at the end, you're going to want to open the warm-up, you're going to want to take note on it, and then at the end, you're going to submit it for a classwork grade for today. So in 2.6, we learned about combining functions and composite functions. So combining functions meant like you could take two functions and you can add them together. You can subtract them from one another. You can multiply them times each other, and you can divide. And if the value inside the variable was just an x, then you would literally just combine your like terms, or multiply in the case of the FG and then combine your like terms. If there was a value inside of the parentheses, then this meant two things. One is you can actually combine the two functions together. So if it was like f of x was x plus 2 and g of x was, 3x minus 1, then if I wanted to do f plus g of x, I could do f of x plus g of x. So x plus 2 plus 3x minus 1. Combine my like terms. And then I could take the negative 2 and plug it in. And I'd get 4 times 2 plus 1, or 8 plus 1, which is 9. So that was one option. The other option is to find f of 2 and add to it g of 2. So f of 2 would be 2 plus 2, or 4. And g of 2 would be to take the g, 3 times 2 minus 1, 6 minus 1, which is 5. And then add those together at the end, and you get the 9. So you have the two options when there's a value in there. Again, you can either combine the normal, or you can plug that value in for each of them and then perform the operation, whether it's addition, subtraction, multiplication, or division. Most of the time, I would say I would go with the second option because less mistakes get made, but I would only pick the first one if by chance they asked you to find the f plus g of x and then find the f plus g of a value. Then it would make more sense just to plug it in. So that was the adding, subtracting, and multiplying and dividing. So something like number 1, number 2. And we'll come back to, I'll pause again at 3 and 4 and review those functions. So for number 1, it says find f plus g of negative 1. So I can find f of negative 1 and add to it g of negative 1. For f of negative 1, I come back up and find f, which is 3x minus 1. So 3 times negative 1 minus 1 would be negative 3 minus 1, or negative 4. And then I want to find g of negative 1. So I go back to my g of x and I plug in a negative 1. So negative 1 plus 2 times negative 1 minus 1, 1 minus 2 minus 1, or negative 1 minus 1, which is negative 2. And then because it was addition, I add these two together and I get negative 6. And that's the solution I'm looking for. For number 2, it says to find the domain. We'll find f over g of x and then find the domain. So put f in the top. 3x minus 1 would go on the top. G of x would go on the bottom. X squared plus 2x minus 1. That is the first part, f over g of x. Then finding the domain of your combined function, I have to look at what I just found and see if there's any restrictions. So as a review of domain, it is all real numbers except if there's a variable in the denominator. And in those cases, we set the denominator. So if there's a variable in the denominator, we set whatever's there not equal to 0. If there's a variable underneath a square root, and we would set whatever's underneath the root greater than or equal to 0. Or the combination of the two, variable in the denominator under a square root, and that we would set whatever's underneath the square root greater than 0. So when you're looking at this example and you look at the denominator, because that's what we're worried about, I would say x squared plus 2x minus 1 cannot equal 0. And then I would see if I could solve this. So if I want to factor it, are there factors of negative 1 that sum to positive 2? And there are not. Negative 1 is just negative 1, and 1, that wouldn't sum to 2. So then if I had to solve it another way, it would be quadratic. A would be 1, B 2, C negative 1. I'd get negative B plus and minus the square root of B squared minus 4 times A times C all over 2 times A. I'd get negative 2 plus and minus, this is 4, plus 4, so the square root of 8 over 2. Simplify that further because you can break that 8 down. Negative 2 plus and minus 2 root 2 over 2, which is negative 1 plus and minus square root 2. And that's what x cannot equal, because then it makes my denominator 0. So x cannot equal negative 1 minus root 2 or negative 1 plus root 2. And the way we write these answers is in interval notation. So the domain would be from the negative infinity to the smaller value, which would be negative 1 minus square root 2, with a parentheses on it because I can't include it. Then it can be all the values in between. So union negative 1 minus root 2 to negative 1 plus root 2. And then union negative 1 plus root 2 to positive infinity. So if it were just one value it couldn't equal, you'd go from negative infinity to that value and then that value to positive infinity with parentheses. Because it can't equal either of these values, that's why it gets a little bit more complicated and we need to expand it. So on the review for 2.6, you're also going to see just questions based on domain. And then you're going to see questions based on domain after composite and combined functions. So speaking of composite functions, this is that FOG, or f of g, or g of f. And what it means is f of g of x would mean take the g of x and plug it in to the x that's in the f of x. So specifically for this one, because g's on the right, that's the one I'm plugging into f. So the g of x is going to get plugged into the x on the f of x. So I'd get 3 parentheses x squared plus 2x minus 1 minus the one that follows. Distribute the 3x squared plus 6x minus 3 minus 1, and I'd get 3x squared plus 6x minus 3. So that's the first part. Second part says find the domain of this function. So when you're finding the domain of a composite function, you want to look at your ending function. So I'll take this one and I would look to see if there's any restrictions. There's no variable in a square root. There's no variable in the denominator. So this would be all real numbers for the composite function. You also have to go back to the one that you plugged in. So the whatever is on the right, the g of x, you have to check that one and see if it originally had a restriction, and if it did, you bring it down. So as it is right now, there was none on the g of x and there was none on the f of x, or none on the f of g of x, which means that the domain is all real numbers or negative infinity to positive infinity. In just a minute, I'll show you an example of what it would look like if it was different. All right, so then f of g of negative 1 for number 4, we're going to do f of g of negative 1, which means take the negative 1 and plug it into the g. So go back up to the g and plug the negative 1 in there. So negative 1 squared plus 2 times negative 1 minus 1. 1 minus 2 minus 1, negative 1 minus 1, which is negative 2. And that's this whole thing gets replaced with negative 2, which means now we're finding f of negative 2. So to do that, we find the f of x this time, and we plug negative 2 in. So 3 times negative 2 minus 1, negative 6 minus 1, which is negative 7. And then that's the only answer. It's not a two-part answer. It is just the last answer. Okay, so to give you an example of one in which you have to go back to your original function. So let's say f of x equals 1 over x. And then g of x equals x plus 3. So if I find the function, if I do f of g of x, I'm taking the g and I'm plugging it into the f of x. So it would be 1 over x plus 3. That's the composite function. To find the domain, I'm going to check the domain of the composite function, and there's a variable in the denominator, so this cannot equal 0. X could not equal -3, and my domain would be from negative infinity to -3, union -3 to positive infinity. And then I would also have to check the g of x, because that's the one I plugged in, to see if there's an additional restriction, and there's not. So that is the only domain restriction, that negative infinity to -3, union -3 to positive infinity. Now, if there was, for example, f of x equals 1 over x, and then g of x equals the square root of x plus 3, I would take my f of g of x. So I'm going to take the g of x, I'm going to plug it in. I get 1 over the square root of x plus 3. That's my composite function. I would check to make sure this doesn't have a restriction, and it does, because there's a variable in the denominator under a root. Whatever's there has to be greater than 0, so x plus 3 has to be greater than 0, and x has to be greater than -3. And then I have to go back to what I plugged into the g of x and see if there's a restriction. The restriction on this one is that it has to be greater than or equal to 0, so x has to be greater than or equal to -3. I have to figure out the overlap between these two. So if one says it has to be greater than -3, and one says it has to be greater than or equal to -3, I pick the more restricted one, which is greater than -3. So the domain of this function would be from -3 to positive infinity. Now we're going to do one more. Let's say f of x equals 1 over x minus 2, and then g of x equals x minus 3. And you wanted to find f of g of x. So I'm going to take the g, I'm going to plug it into the x, 1 over x minus 3 minus 2, and I get 1 over x minus 5. So there's my composite function. The domain restriction here would be my denominator cannot equal 0, so x cannot equal 5. And then I would go to the g, because that's the one I plugged in, and there's no additional restriction. So the only restriction I have is from negative infinity to 5, and 5 to positive infinity. So again, I want to check the one I get as a result and the one you plugged in. If it was the other way around, if I had plugged f of x into the g of x, I'd get the result, but then I'd also come back here and say x can't equal 2. So there's extra domain practice on the assignment for tomorrow's quiz review. For today, you're going to complete the 2.6 homework assignment. I know you've already done one on WebAssign. This one's a PDF. It's going to be on your to-do list. You're going to submit these notes for a classwork grade before the end of the class period, and then you can use the remaining time to work on your 2.6. Also due tomorrow is your 2.6 cheat sheet. So you don't really need it, but you can use one regular size page, one side of it, so just one side, handwritten, not printed, not type. And it can have anything pertaining to 2.6. It will get turned in on Friday. Ms. Ferrier will come by at some point during the class period to collect it. If you do not turn anything in on Friday, then you cannot use it on Monday's quiz. Again, it has to be one side of a regular size piece of paper, and it has to be handwritten, and it can include anything from 2.6. So if you need some rules on domain or the composite functions, some examples, you can totally add them. But again, only what you turn in on Friday during class will be permitted to be used on Monday's quiz. Have a great day, guys.